Everyone, it's Pharmjoe, your favorite chemistry tutor. I want you to take a look at this topic, double bond equivalence. You'll find something like this in undergraduate chemistry, and also for aspirants that are about to write post-UTME, you can find question around this. Now, let's take a look at this. Double bond equivalence. To calculate or to solve question related to this, the first thing is that there's a formula. Thank God for a formula. Double bond equivalence equals carbon, number of carbon plus 1 minus number of hydrogen over 2 minus number of halogen. Your X is halogen. X can be chlorine, bromine, iodine, and like that. So plus n number of nitrogen over 2. So how do we solve this? We can solve this question in two ways. The first is that I can decide to use this formula. And when do I use this formula? When is it easy for us to use this formula? It will be easier for us to use this formula if you already have your molecular formula. Now, this compound, which is a bromobenzene, this is the molecular formula of this compound, is having 1, 2, 3, 4, 5, 6. You can see it's having 6 carbon. The hydrogen here is we have 1 hydrogen, 1, we have 2, we have 3, we have 4, we have 5. So C6, then we have H5, 1, 2, 3, 4, 5. Then we have Br. So when do we use this formula? We use this formula when we already have our molecular formula. And we can easily solve this question from here. Our DBE is equivalent to, what's the number of carbon we have? The number of carbon we have here is 6 plus 1 minus, how many hydrogen do we have here? We have 5. That will become 5 over 2. Then our X, which I call your chlorine, bromine, or iodine, which is your halogen, we have 1 bromine here, which is minus 1 over 2, then plus n over 2. Since we do not have nitrogen, we don't have nitrogen here, so we are going to omit it as if it's not part of what we are doing. Now, very simple. I can have 6 plus, by the time you do the whole of this, 1 minus 5 over 2, doing your maths here, we should have minus 2. We should have minus 2. If we do your maths very well, the whole of this should give us minus 2. Now, 6 minus 2 will give us 4. So the DBE of this bromobenzene is 4. That is one way of going about this question using the formula. Another way of going about this question without using the formula is very, very easy. The first thing you must pay attention to, if you don't want to use your formula, is that you must have the structure. So with the structure alone, I can determine the DBE without using this formula. Once I have my structure, the very first thing I pay attention to is that a ring, anytime you have to use the structure, you pay attention to the fact that a ring, just one ring, is equivalent to 1 DBE, which is 1 double bond equivalence. What is a ring? I mean, ring can be any shape. You can see that this shape is 6-sided. We can have any shape is representing your ring. Any shape is representing your ring. So this is 6-sided. We have 5-sided ring. So anytime we have a ring, that means any shape, it means it is 1 DBE. Another thing is that another thing you should pay attention to is 1 pi. Pi bond is equivalent to 1 DBE. 1 pi bond is equivalent to 1 DBE. Now, and you know in organic chemistry, if you have a double bond, 1 is pi and 1 is sigma. If you have a triple bond, then 1 is sigma, 2 is pi. Remember, if you have a single bond, it is just a sigma. If you have a double bond, 1 is sigma, then 1 is pi. And when 1 is pi, 1 is sigma. Now, if you have a triple bond, you can have 1, 2, 3. This is the case of triple bond. If you have a triple bond, 1 is sigma, then 2 is pi. So let's go back to this structure. I want to use this structure to determine the DBE without using the formula. Very simple. First thing, is this structure having a ring? Yes, it has a ring. What's the ring? A 6-sided ring. So a ring will equivalent to 1 double bond. Do you remember? So this guy is having 1 ring, which is 1 double bond. Then another thing I said is that a pi bond, 1 pi bond is equivalent to 1 DBE. Now let's take a look at this compound. How many pi bond can we see here? This is sigma pi. this is sigma, this is, so I told you that anytime we have a double bond, one is sigma, one is pi. So we have 1 pi here, 1 pi here, 1 pi. How many pi do we have in total? 3 pi. Since 1 pi is 1 dBE, if we have 3 pi, it means 3 dBE. So 3 pi bond equivalents to 3 dBE. So now let's add the two of them together. We have one ring, which is 1 dBE. We have 3 pi, which is 3 dBE. So 1 plus 3 is going to be giving us what? 4. Very simple. Now, I want you to try question on your own. I want you to try this question. I'm going to rub up this part, or probably, yes, let me take up this. Let me take up this part. Let's see if we can have this. I want you to try this question yourself. Can you try this something like this? Let's say we have something like this. Let's say we have triple bond N. Triple bond N. Let's make it sophisticated a little bit. So that it will be more interesting. Let's play with it. Let's say we have N and double bond O to, let's say we have something like O. This place should be plus, this place should be minus. I think this question is good to go. This is the question I want you to try. I want you to try this question. How many dBE? What is the dBE of this question? If I'm to put all of them maybe in a molecular formula, it should give us I think C7H4, then N2, then O2. So try this question. Try it using the structure, try using the molecular formula. Don't forget, anytime you have to use the formula, you must have your molecular, if you want to use this formula, you must ensure you have the molecular formula written out. If you want to use the structure alone, there's possibility of using the structure alone to get the answer like I did. So I want you to try that question. Drop the answer in the comment section. Thank you very much.